Some time ago I showed you how to execute encrypted shellcode in memory, and although encryption in general reduces detection rate, it often doesn't quite solve the problem, because the payload is still there, hard-coded in the file. But what if we could store it somewhere else? Somewhere where we can reach it exactly when we need to. That's where payload staging comes in, a technique of separating payload and a small piece of code called a loader or a dropper. Loader's task is to establish foothold on the target machine and send message to the server controlled by attacker saying, "Hey, I'm in, send me the good stuff." And server replies with, "Yeah, sure, here's the payload," and then loader executes it. It doesn't only make detection harder, it also allows attackers to just modify the payload while loader stays the same. Imagine two identical malwares at first glance can do completely different things. But I'm sure you already want to see the code that does all the magic, so let's jump right into it. Those of you who have watched the encrypted shellcode video already see that this is just a modified version of a code from that video. So I don't really want to explain all of this, what's going on here. Go watch that video, you will know everything and come back here. But just as a simple recap, this is a key to use to XOR encrypt the payload. This is the AES key, this is AES IV, and we have this shellcode variable that holds the encrypted payload. We first decrypt it using XOR, then we decrypt it using AES library, and we execute it in memory. As you can see, instead of saving the shellcode in variable, it's commented here, I use this download shellcode function, which is new. It takes a URL, which is this URL to encrypted.bin, and also two addresses of variables that will hold downloaded payload and payload size. So let's check this download shellcode function. As you can see, it starts with internet open W, which initializes the internet connection, sort of. It is a part of WinInet library, so make sure you include it at the top. And it takes 5 parameters. 1, 2, 3, 4, 5. Yeah, I'm right. So let's check it out in Microsoft documentation, Windows API documentation, link in the description, of course, as always. As you can see, it initializes an application's use of WinInet functions. And the first parameter, this shellcode downloader string, is just the name of the user agent, so this is the completely, you can basically pass any name here, whatever you like. The second one, kinda important, type of access required. We want internet open type direct, resolves all host names locally. That's the value that we want to specify here. Third parameter, let me quickly check. Yeah, all of the others are null, null, and 0. So basically this and this is used while you are using internet open type proxy. We are not using this, so I don't really want to waste time going over those. But if you will use it in your project, then sure, check it out. And we are not using it, so as you can see, if DW access type is not set to internet open type proxy, this parameter is ignored and should be null. Same goes here. DW flags, also we don't use them, so we just pass 0 here. And let me go back to the code. And with the internet connection initialized, we want to get the file with internet open URL W, again, the wildchar thing. And also those if checks, yeah, pretty standard thing. If this fails, bool success equals 0 and return success. Sure. Sure thing. All right, so internet open URL W. Also, let's check it out in Microsoft documentation. Really, this is a gold mine. I said it in every video, I know, but it's true. So it opens a resource specified by complete FTP HTTP URL. As you can see, those are the protocols that we can use to download files with this function. So the first parameter is a handle to current internet session. So this thing, hinternet. Second parameter is our URL. third parameter is LP as the headers. Those are the HTTP headers that we want to send to the server. We don't need to send any, so we pass null here. And the DW headers length, if there are no headers, there is no length, so length is equal 0. That's why you have null here, and 0 here. Next thing, I specified here 2 flags, which are DW flags. This parameter can be one of the following values. I mean, as you can see, it can be multiple. Oh, wait, if you go with end. But it basically means, for example, this flag means that we'll be ignoring cert date invalid. It means that if the certification is invalid, the SSL certification, we just don't care. And in my case, I will be using, to test it, I will be using the Python HTTP web server, so I won't have any valid certificate for it, so obviously it will be invalid. But you can read through other flags. What we can do here, there is a bunch of them, as you can see. So this function might be pretty complex, has a lot of options. So yeah, you can check it out, definitely, do some research. And DW context, we don't use it, so we just passed 0 here. All right, so once we have our file, and by the way, this is the download, the function that actually does download. When you open up a debugger and go through this function, you will see on the server logs that the file was downloaded. So next thing, we want to read it to the buffer. And of course, once we create a payload, we know the size of it. But let's assume that, as I said at the beginning, we want our loader to be able to load whatever payload we want. Loader needs to stay the same, payload can change. So we need to make loader be able to load payloads of various sizes. So it needs to be flexible. And we do it with this simple do while loop. First we use internet read file function. Oh, okay, first we initialize some variables. pbyte shellcode size, byte read, and a buffer. What they will do, I will say in a moment. But first, internet read file function, go to the documentation again. So it reads the data. It reads data from a handle opened by one of those 3 functions. This one in our case. All right. So the first parameter is handle returned from previous call to internet open URL. So we have it here, HURL, this handle. Second parameter is a pointer to a buffer that receives the data. Sure enough, here's the buffer. Second parameter, number of bytes to be read, 1024. That's just the number that I specified. You can specify something else, but yeah, 1024. That's my choice. And the last parameter is pointer to a variable that receives the number of bytes read. So this is the thing. We will attempt to read 1024, and the number of bytes that we actually read will be saved in bytes read variable. So first we use this internet read file to get the first 1024 10,024 bytes. We save it to the buffer. Then if we actually read any bytes, if bytes read is greater than 0, we create a temporary buffer that we attempt to reallocate we attempt to resize this shellcode block, right? So the realloc function, basically what it does is it takes pointer to one buffer, right, and it to the memory block, and it attempts to resize it to this new size specified here, which is shellcode size plus bytes read. And if it succeeds, we do shellcode equals temp. We copy the memory, and memcopy works like this. You have destination, source, and the size. And why is shellcode plus shellcode size here? This is a pointer to a location in memory. Shellcode size is some shellcode size. So it basically works like this. You take this pointer to the shellcode variable, and it points to the beginning of it. And we want to, with this function, we want to add the next part. Because as you can see, it's first 1024, but if our payload was to have, for example, 2048 bytes, we would first save 1024 and then repeat this loop and save another 1024. So we want to add this second block to it. So we need to figure out the location where do we sort of connect those blocks. So the location is the beginning plus the size. So the beginning, let's say the beginning is 0, size is 1024. So the new beginning will be 1024. I hope it's clear. You will probably see some graphic or animation explaining this, but yeah. So the source is of course buffer, the data that we just read in this loop rotation, and bytes read is the number of bytes, the size of the buffer that we read. All right, not the size of the buffer, but the amount of bytes that we read. All right, and we then increment, we then increase shellcode size by bytes read. And we do it until we read 0 bytes. So until the whole file was saved, basically. Yeah, and after it, we close the connection and make sure to save the shellcode and shellcode size in those pointer variables so that we can receive our payload and payload size here. So basically, that's how the whole download logic works. As you can see, after this function, it returns bool success. I actually forgot to make an if statement that will terminate it if something goes wrong, but you can do it by yourself, I'm sure. And as you can see, inside the char pointer shellcode, it is this. This variable will hold the downloaded payload here. And then we use this shellcode later. Later we decrypt it, perform the whole XOR and AES decryption, right, and execute it in memory. All right, so let me open up my Kali machine and show you how this works. Now, just to clarify, I'm creating the encrypted shellcode, or more like encrypted the shellcode created by MSF Venom with this file. That's almost exactly the same script as in the previous video, as in the encrypted shellcode video, with the one tweak to it. I'm also saving not only printing the encrypted shellcode to the screen, but also saving it to this path with save to file function. And this function looks like this. Pretty basic. We just open a new file and write the data to it. So that's it. Of course, both this code and the run shellcode code, so both of them are in the link in the description on my GitHub. So yeah, you can download them from there. Okay, so once you have your Kali machine up and running, let's do some configuration. First, we want to open up MSF console by typing MSF console like this. Wait for it to load. And now type use multi-handler. This tool that we will use to capture the connection, the shell. So type options to see the options that we can provide. So you can see we want to set payload lhost, which is the IP address of our Kali machine, and the L port is 4444, which is already correct, because as you remember from the previous video about the encrypted shellcode, we generated a shellcode with MSF Venom using this payload, this IP address as lhost, and this port, and also exit func thread, which we will set now. So first set payload to Windows x64 meter reverse TCP, like this. The value specified is not valid. Windows x64 meter. Okay. 1E is missing. Okay, now it's valid. So now if you type options, you see there's another option called exit func. So type set exit func to thread, like this. And now one more thing, set lhost to 192.168.0.130. And now all the options are set. If you click enter here, if you run this command, you will be greeted with this shellcode that you just need to copy to the encrypter. So it takes this shellcode and encrypts it with the key and with the XOR key and with the AES. Right. So let me run this code. As you can see, it generated a file on the desktop. Okay, you can see it now. So drag and drop it to the Kali machine. And we have it here. Now we want to make it accessible. So we run a Python -m simple HTTP server on port 80. So that our loader can download it. Let's call it encrypted 1. Or maybe encrypted 2, because I did a bunch of tests, and it seems that this function, this download shellcode, is caching this file for some reason. I mean, if I run this code more than once, it connects to the handler, but doesn't download the file. I mean, it does, but it doesn't show it in the logs. It's quite weird. Maybe some of you know why is that. So leave it in the comments, the explanation. But yeah, when you type run, as you can see, it started reverse TCP handler on 192.168.0.130 4444. So we are waiting for connection, and with Windows Defender disabled for now, let me run our loader. So hit run, wait for it, and it throws this error for some reason. And the reason is that I forgot to copy the keys. All right, so this encryptor software returned the new AES keys, AES key and AES IV. So I forgot to replace it, and loader couldn't decrypt the shellcode. So let me quickly copy it here. My bad, sorry. And let's run it one more time. As you can see, we got this. Actually, oh, that's the very cool. It's very cool now because I can show you this weird behavior. We got the download, so that was successful. You can see that this function actually worked. Then we read the file, right, and we failed here. I mean, we failed further, but initially we failed here because we decrypted with the wrong key, so it was a mess, not a reverse shellcode. But what will happen now? When I run it, it will trigger a shell, and it will trigger another download. So that's cool. So now we can type shell. Who am I? And you can see that it's perfectly working. I have no idea why right now it worked. Previously, when I was testing it, the second time I was running the script, it wasn't displayed in the logs for some reason. But right now it got displayed. So let me know if it's only sometimes buggy for me. Maybe you are you have the same sort of weird behavior. I don't know. But yeah, overall everything is working fine. We have our stager server working here. We have our code downloading. the actual payload on runtime. We don't keep it saved here. You can delete it safely, but I will leave it here just for debugging purposes and for presentation. And yeah, you just got yourself a fully working payload loader. Thanks for sticking till the end. Make sure you leave a like and subscribe so you don't miss any new content. And if you have any feedback, you want me to do something different or say that I'm doing something right, leave it in the comments below and see you soon.